right. I'd like to end today with just kind of brainstorming here for just a minute. What you can use this optimization algorithm for in Excel. So let's just brainstorm. What are some examples of how you can use this? And you know, we just used Excel today, but you can use these same methods in Python, and we'll go over some of those tomorrow. But can you think of examples of when we could, of different things we could use these tools for? No ideas, huh? Okay, let me give you some examples then. How about just solving equations? So let's say that I've got some big nasty function, right? F is a or F as a function of X, Y, Z, whatever. You know, it's some big nasty function here, and I want to say I need the values of X, Y, Z that will give me a very specific value out of this. So let's say that we need to find X, Y, Z that's going to be equal to 5, right? Well, in Excel, they've got a nice little button there that lets you do that. When you say, okay, I want to solve this, I can say, yeah, I want that objective to be equal to a value of 5, right? So rather than minimizing it, I want the objective to come out to be exactly 5. Well, we can do that too, just by rearranging how we set up this problem. I'll just solve that just to get it off my. Okay, so there you go. It got a value of 5 and it still satisfied that constraint. It came up with something that was above 1 anyway, so that didn't really matter. But we can just say that we want to, that our black box is going to be that function, f of x, y, z minus 5. If we take that function and subtract off 5, then what we're really trying to do is find the value where this is 0. And maybe if we took this thing and squared it, then now we've got a function that's going to go to 0 actually quadratically, which is really nice for gradient-based optimization algorithms, right? So if we were to set this now as our objective function, then we could again say we just want to minimize this function, and the solution is going to give us exactly a point that equals 5 for the objective function. Does that make sense? Okay, so you can use this to solve equations, and I do that all the time. I use it regularly for that. Another thing is, how about equation fitting? Okay, so if I've got, let's say that I've got a bunch of points over here, and I need to fit an equation to that. I need some equation that represents that series of points, right? Well, again, Excel has a really nice feature for this where let's just take these points here and we'll insert a plot with those. That's not very exciting. Let's do this one up here. Okay, so there's a series of points, right, that we might have gotten from data, whatever, and we can right click on that and say add a trend line, and it gives us some options over here. So linear isn't very good, but that's just a straight line trying to represent that. This is probably a polynomial of order 2, and in fact, if we were to display the equation and the r² value, you can see that that is going through those points exactly. That's because this is a quadratic function, right? And we just fit a quadratic, a polynomial of order 2 to a slice of that domain. And for quadratic functions, any of those slices can be fit to a polynomial of order 2, basically. So you can see that it found that exactly. And there are analytic ways of coming up with this. But what if, there's only so many options over here. We can do an exponential, we can do a linear, we can do a logarithmic. Sorry, I didn't like that because some of my values went negative. We can do a power. Didn't like that one either. We can do a moving average. Anyway, there's only so many things we can do there. But what if we wanted to fit this to some other equation of a specific form that we had that that we wanted to force on that equation and find out, maybe we wanted to fit this to a sine wave, for example, right? And this is just a section of that sine wave. We wanted to find out what the frequency and amplitude and offset or whatever of the sine wave is that goes through that data. Well, we can do that really easily by, I'm going to kind of mess up some things here, but we would put in our equation in another column, and it's going to depend on some inputs here. So in fact, let me just move some stuff over here. So maybe we have an amplitude and a phase and a frequency. Anyway, we can have values for each of these that we would drop in these boxes, and then we'd say, okay, over here in my function column, I'm going to say this is equal to the amplitude times the sine of the frequency times some independent variable x plus a phase shift. Anyway, so we can do that. We'd have to freeze those cells or whatnot, but copy all of that down. And now we'd have an estimate, based off of this amplitude, phase, and frequency. This is what my function says is the value at each of these x locations. Does that make sense? And then I could insert another column here and say, well, this is the error. So this is the function value, the estimate from my thing, and then this is the actual data, for example. I don't like that, but you guys get the picture here.